Okay, this is the release question from AP Calculus in 2008. Question number 5, about differential equations and drawing a slope field. Okay, so you can see here, this is your dy dx, right? This is your differential equation where x does not equal 0, of course, because if it does, there'd be a vertical asymptote. Okay, so what you want to do for part A is, of course, sketch all of your slopes on the grid that they give you. Okay, you only have to plot the slopes on the line, the dots. Okay, so notice that there's no dots along the y-axis, so you don't have to put any slope lines here, just where x is 1, x is 2, and x is -1. Okay, so that's going to be the first thing we do, is write all of these slopes on our graph. So let's see, let's start at the left. When x is -1, that would be 0 minus 1 over -1 squared. Okay, which is -1 over 1, which is a slope of -1. So you will draw your -1 slope in right there. Okay, so let's move up 1 now, and we're just changing your y value, right? So y is now 1, so 1 minus 1 is 0. So here, at when y is 1, we have a slope of 0. In fact, everywhere that y is 1, we're always going to have a slope of 0, because it's always going to be 1 minus 1 over something, which 0 over something is always 0. Okay, so let's move up to the next one here and do 2. 2 minus 1 over -1 squared is a positive 1 slope. So here at positive 2, we're going to have a positive 1 slope. Okay, done. Now let's move over to where it's positive 1. Okay, so we're going to change your denominator now to positive 1 squared, which is just 1, so that's not really a big deal. 0 minus 1 over 1 is once again -1, so here at 1 comma 0 we have a -1 slope. At positive 1 y value we have a 0 slope. And what about at 2? When y is 2, 2 minus 1 is still 1, so we once again have a positive 1 slope at the point 1 comma 2. Now let's change over here to 2. So now we're changing your denominator. The denominator is now 2 squared, which has a denominator of 4. Okay, so our denominators are all going to have a denominator of 4. So we have 0 minus 1 over 4, which is -1/4. So pretty flat. -1/4 is the slope at 2. What about 2, 2? So if I move up here and I change my y value to 2, 2 minus 1 is now a positive 1. So we have a positive 1/4 slope at the point 2 comma 2. So now that we have our slope field drawn, we can do part B. Find the particular solution to this differential equation with the initial condition that when x is 2, y is 0. Okay, so there are 3 steps. The first step to doing any of these is to separate your variables. Okay, get your y and your dy on one side and get your x and your dx on the other side. Okay, whatever they happen to be. Get your y's on the left side and your x's on the other side. Okay, so we separate your variables. Step number 2 is to integrate. You take the integral of both sides. Right, that's how we get rid of the dy in our differential equation. Okay, the third step is to solve for c. Because anytime we take an antiderivative, we always have that plus c constant. Okay, so we're going to use the initial condition in order to solve our problem for c. In this case, that's the point 2 comma 0. And then, once you have solved that for c, we're going to solve your equation for y. Okay, and these are your 4 steps. Separate your variables, x and dx on one side, y and dy on the other. Integrate, right, to find the antiderivatives. solve for c using your initial condition, and then solve for y at the end. So let's get done this business. So dy over dx, let's make it bigger so I have more space. You're going to need more space from this, by the way. Dy dx equals y minus 1 over x squared. So what ends up happening when we multiply and divide is we simply have to switch these two positions. Okay, this is part of your equivalent ratios. Okay, so if you're talking about ratios, right, if you have this as your ratio, that's the same as if you switch this numerator and denominator, the ratio stays the same. Okay, but what happens is your dy's, of course, are now on the left side, and your dx's and your x's are on the right. Right, so you would multiply both sides by dx, and then you would divide both sides by y minus 1, and this is what it turns out to be. Okay, so you can directly integrate this if your brain is capable. So I'm going to pull the dy out like this. Now I'm going to pull the dx out also like this, so that I can now recognize what my antiderivatives are going to be. Okay, hopefully you are familiar with this one. 1 over y minus 1 is the natural log antiderivative of absolute value y minus 1. Okay, so 1 over y minus 1's antiderivative is the natural log of y minus 1. Okay, in absolute value, because we need it to be positive. Okay, when we anti-differentiate, you're only going to have your c on your x side. We're not going to worry about having multiple c's here. So this one is also known as, let's change the color real quick. This is x to the negative second power. Right, so when we anti-differentiate x to the negative second, we add 1 to the exponent, making it x to the negative 1, and we divide by that new power. So x to the negative 1 divided by negative 1 plus c. So now let's plug in our information. We know that when x was 2, y was 0. So the natural log of 0 minus 1 in absolute value equals the negative of 1 over 2 plus c. Okay, so up here it said when x was 2, when x is 2, y is 0. So this is our initial condition. You plug in your initial condition in order to solve this for c. Okay, so let's come up here. I have the natural log of absolute value of negative 1, which hopefully you know is just positive 1. So we have the natural log of 1 equals negative 1/2 plus c. Okay, and what is the natural log of 1? That is 0. So when we add 1/2 to both sides, we can know that c is 1/2. Okay? So we have now solved this equation for c. I have the natural log of y minus 1 in absolute value equals the negative 1 over x plus 1/2. Okay, so this is our formula that we have to solve for y. Okay, we use the initial condition to solve it for c, and now we have to solve this one for y. So I hope you have some space. This could take a little bit. So first thing is, how do we get rid of this natural log? We make it to the base of e. Okay, so I don't know exactly what this is called. It's under exponentiating or it's raising to a power. But if we raise both of these things to have a base of e, okay, now they are both exponents. And e and natural log, they get rid of each other, right? They cancel out, they undo, they whatever you want to call it. So y minus 1 is equal to e to the negative 1/2. Nope, not negative 1/2. negative 1 over x plus 1/2. All of that is in the exponent, okay, with a base of e. So absolute values, right? Absolute values can be positive and absolute values can be negative. So we're going to figure out which one it is. Okay, so we either have y minus 1 equals e to the negative 1 over x plus 1/2, or y minus 1 equals negative e to the negative 1 over x plus 1/2. So absolute values can be positive and absolute values can be negative. So when we have this in absolute value, we have to split it into two equations and pick which one is the very best. Okay? So this is how we do it. Up here in our problem, we were told that when x was 2, y equals 0. Yes, that was our initial condition. When x was 2, y was 0. So what we're going to do is we're going to replace x with 2, just the x value. We're going to replace just x with 2 and see if y is 0 when you do that. Okay, we're going to verify that one of these is actually going to work. And usually only one will, normally both of them will not. So let's see which one works. Okay, so y equals 1 plus e to the negative 1/2 plus 1/2 is 0. E to the 0 is 1. 1 plus 1 is 2. Okay, so in this case, if x is 2, y is 2, so this one's probably not going to be our answer because it doesn't give us the y value that we need. So let's verify over here that it actually does. Remember, negative 1 plus negative 1/2 plus 1/2 is 0. Okay, and e to the 0 is once again 1. 1 minus 1 is 0, and that's exactly what we needed. When x is 2, y is 0. Okay, so this is the formula that is going to be our y value. Okay, so f of x, also known as y, is 1 minus e to the negative 1 over x plus 1/2. Okay, and I brought the 1 over to this side to solve it for y completely and get y by itself. So y equals 1 minus e to the negative 1 over x plus 1/2 power. Okay, so there's lots to do here, right? First you have to separate your variables. Then you have to integrate and anti-differentiate. Use the initial condition to solve for c. And then once you solve for c, you have to then solve for y. Okay, whenever we have a natural log situation and an absolute value, you have to break that into two equations and see which one gives you your initial condition. See which one is correct. Okay, and the last part, part C, find the limit as x approaches infinity of our function. Okay, so this is back to our first unit, the limit as x approaches infinity of 1 minus e to the negative 1 over x plus 1/2. Remember, that's the function that we found up here, so that's the function that you're going to use down there. Now, say on AP you got your first function wrong. You got this part wrong, but then when you plugged it in down here and took the limit, you got it correct. Well, you'll still get the points for the second part, but not points for the first part. Okay? If you take the limit as x approaches infinity correctly. So remember what that means. That means we are replacing x with infinity plus 1/2. So what we're going to do is use our rules of exponents and split this into two, right? So this is times e to the 1/2. And if we're raising it to a negative power, right, that's the same as if it were in the denominator to a positive power. So 1 minus 1 over e to the 1 over infinity power times e to the 1/2 power. Okay, so when we have a plus with your e base, we're going to split it into a multiplication of 2 e bases. Okay, so let's do some investigating here. 1 over infinity. 1 over a really big number is a really small number. Basically 0. So e to the 0, once again, what is e to the 0? Well, that's just 1. So we have 1 minus 1 over 1, which is 1, right, times e to the 1/2, which is a number, right? That's a fantastic number. I know nobody likes this number because it's really hard to understand, but 1 minus e to the 1/2 would be the limit as x approaches infinity. Okay, maybe you want to write it 1 minus the square root of e. Maybe that sounds better to you. I don't know, but those are both equivalent equations. Okay, and that is the answer, and we're all done with this FRQ. Okay, so this is how the AP test is going to test you on slope fields and anti-differentiating those things.